Okay, so here I have a log equation with a whole bunch of stuff on the left, and it equals 6 on the right. And what we've been doing so far is combining logarithms, condensing logs, if you remember the word. And if we can get this in terms of one logarithm on the left equals a number on the right, then we can use an exponential conversion to turn this into a solvable equation. So let's take that idea, and I'm going to start working on this one. Let's just assume this collapses somehow. I'm going to go ahead and write this as a logarithm. And if you notice, one nice thing about this is it's a big mass, but look at what we have here. Bases of 2. They're all base 2 logarithms. That means you can form this into a single logarithm base 2. It's like a megalog of all these individual components packed together. On the right, it equals 6. And let's just think about where each of these terms goes. If you remember the product rule and the quotient rule and the power rule, those are going to all come into play here. So I'm going to start using different colors here. Let's say I'm looking at this term first. I have a negative log of x. Well, that means the argument x goes on the bottom of this megalog. And in the next one, I have a positive log of x squared. So that means I have an x squared term on top. And in the last one, the third one over here, take a look what we have. We have a positive 4 log of 2x. Well, one thing that tells me is I'm taking the 2x term and I'm putting that on top. But because the coefficient is 4, remember what that means. That means we're taking this 4 and we're putting it on top in the exponent of the argument. So this is 2x to the 4th power. And it's important to remember it's 2x inside the parentheses with a 4 on the outside. If you were to just write this as, 2x to the 4th, that would be wrong. It's really 2 to the 4th, x to the 4th. Okay, so keep that in mind. Now, we have everything written in this big argument here. We can just go ahead and start simplifying. So this is going to be log base 2 of, x squared on top, and 2 to the 4th power, 2, 4, 8, 6, that's times 16, and then times x to the 4th, all divided by x, equals 6. And you can see there's some things in here that are going to simplify. Let's just do that really one step at a time. X squared times x to the 4th, that's x to the 6th. It's going to be 16x to the 6th divided by x. And an x cancels out from both of those. So I get log base 2 of 16x to the 5th equals 6. And that's about as simplified as I can make this. At this point, let's turn this into an exponential equation. I'm going to convert this to 2 to the 6th power equals 16x to the 5th. And remember, if you're unfamiliar with where this is coming from, remember, anytime you have something written this way, b to the c power equals a, that goes back and forth with this statement. Logarithm base b of a equals c. And if you look over here, if you look between these two parts and you try to match up what's the base, what's the argument, what's the exponent, you can see everything's going to line up. And now I have 2 to the 6th power. Well, that's just, what is that? That's just, I have to do this every time. 4th power is 16, 32, 64. I think that's 64. I'm going to cross our fingers there. And then over here we have 16x to the 5th. So divide each side by 16. We get 4 equals x to the 5th. And now I have the 5th root of 4 equals x. And that'll be the solution to this one.